All right. How much heat is required to convert a 120-gram snowman from negative 10 degrees Celsius to 108 degrees Celsius? Now, in this case, we're still dealing with only one substance. We're dealing with water. But we're dealing with water in 3 different states. It's going from negative 10 to 108 degrees Celsius. Now, the first thing I'm going to do is I'm going to draw that heating curve, because that's going to make this a lot easier for me. Actually, that's a terrible heating curve. I'm going to redraw this graph. Start like this. I'm going to say this is negative 20 down here. I'm going to say this is 0. I'm going to say this is 100. Now, in this case, we are starting from negative 10, moving to 0 degrees. And then the solid ice is going to melt, and there's going to be a phase change, followed by an increase in energy, thermal energy, up to 100 degrees, followed by another phase change, where the water boils to water vapor. And finally, another 8-degree increase in temperature. Now, in this case, we have quite a few Q values. In fact, we have Q1, Q2, Q3, Q4, and Q5. So this problem is going to be a little more extensive. Now we have to identify where is the phase change and where is the increase in thermal energy. Well, the first thing we can do is look at Q1. And we know that at Q1, it's going from negative 10 degrees Celsius, right there. The temperature change equals negative 10 to 0, which is equal to just 10 degrees Celsius in terms of the temperature change. And we know that the mass is going to be equal to the same thing throughout the entire process, 120 grams, assuming that we don't lose any of the water vapor when it boils. 120 grams, and the specific heat of ice in this case, where it's blue, it's going to be solid ice. The CS, specific heat of solid ice, right here, is 2.1 grams per joule Celsius. Joules per gram Celsius, excuse me. So when I do my first Q value, it's going to be M times CS times delta T. And that's going to be 120 grams times 2.1 joules per gram degree Celsius times 10 degrees Celsius. The degrees Celsius are going to cancel out. The grams are going to cancel out. It's going to be 2.1 times 10, which is equal to 21. And 120 times 21 is equal to a total of 2,520 joules, or 2.52 kilojoules. 2.52 kilojoules of energy. Now let's check out Q2. For Q2, we are undergoing a phase change from solid, and we still have 120 grams of solid ice, are melting and turning into liquid water. So the delta H of fusion in this case, which is the melting, is equal to 6.0 kilojoules per mole. So we're going to have to convert 120 grams of water. For every 1 mole, it's about 18 grams. I got that by doing H2O, which is 2, 16, 18 grams per mole is the molar mass. And I'm going to end up with 120 divided by 18, which is exactly 6 2/3 or 6.66 moles. And so for this equation, it's going to be M times delta H, or love that bell. 6.66 moles times 6.0 kilojoules per mole. And we're going to end up with 40 kilojoules once the moles are crossed out. And that's the value for Q2. Now let's go to Q3. Q3 right here is another addition of thermal energy. Q3, we're going from 0 degrees to 100 degrees, so the change in temperature is going to be 100 degrees Celsius. The mass is the same, it's 120 grams. The CS in this case, though, is the amount of energy required to heat liquid water, CS liquid, which is 4.184 joules per gram Celsius. Now, if we put this all together into M times CS times delta T, we're going to get 120 grams times 4.184 joules per gram degree Celsius times 100. So that's going to be the same thing, degrees Celsius. Thank you. When I cross out the units, I'm going to end up with 120 times 418.4 joules. And my value is going to be, and let's keep that color in red for just consistency, it's going to be 50,208 joules, or 50.208 kilojoules of energy. Now, we've gone through 3 of them. We have 2.52 kilojoules, 40 kilojoules, and 50.208 kilojoules. We're almost done. We have 2 more values to deal with, and that is the the boiling of water in Q4 from liquid water to water vapor. In this case, once again, it's a phase change, so we're dealing with mass, which is 120 grams, times the delta H of, or the delta H of condensation, right here, which is negative 40 kilojoules per mole. Now this is talking about condensation, when it's going from a gas to a liquid. And we know that anytime there's a phase change, the value is still the same, but if we're going in the opposite direction, we change the sign. So for delta H boiling, or vaporization, the value is going to be just equal to positive 40.7 kilojoules per mole. 40.7 kilojoules per mole. Now, we already did the calculation to find out that 120 grams is equal to 6.66 moles. So let's just replace that. 6.66 moles times 40.7 kilojoules per mole. And when we do the calculation, we're going to end up with 40.7 times 6.6666 equaling out to about 271.33 kilojoules. All right. Now, last but not least, we have Q5. Q5 is the last change in temperature, which is from 100 to 108 degrees, which means that delta T is equal to 108 minus 100, or 8 degrees Celsius. We know that the mass is the same thing, it's 120 grams, and the CS in this case is the amount of heat required, the amount of energy required to raise gas, water vapor, 1 degree Celsius, which is 1.7 joules per grams 10 degrees Celsius. 1.7 joules times per gram degree Celsius. So when we do this final one out, we get 120 grams times 1.7 joules per gram times degree Celsius times 8 degrees Celsius. When you cross out the units, you end up with 120 times 8, which is 960, times 1.7, which is a total of 1,632 joules, or 1.632 kilojoules. Now I'm going to stop for a second because I've just calculated 5 Q values right here, which is what's required to go from solid ice to water vapor, because the heating curve asks for 5 Q values. That is the largest number of Q values you'll be expected to calculate in any setting. Now when I add them all up together, it's going to look like this. So the total, Q total, is equal to Q1 plus Q2 plus Q3 plus Q4 plus Q5, which is equal to 2.52 kilojoules plus 40 kilojoules plus 50.208 plus 271.33 plus 1.632. Now, doing the math is going to add up to a total of 365.69 kilojoules, which, if I were to do sig figs here, would be 366 kilojoules. And that is your final answer. Now, nothing is going to get more complex than that. That's as many Q values as you could possibly calculate, so I know this took a long time, but this is the most they'll ever ask of you to do, and it's unlikely they'll ask you to do that because it's just time intensive. But there it is.